Hey there, everybody. This is Mr. Piercy. I hope wherever and whenever you find yourself watching this video on how to work with equations of circles that you're doing well and everything is okay in your world. So this is exactly what we're going to be talking about today is how you can write the equations of a circle based off of the information that you're given in the problem, or maybe based off of a graph that it was given to you. Or if I give you the equation of a circle, can you graph said circle? Now, in the vocabulary box, the standard equation of a circle is going to be x minus h quantity squared plus y minus k quantity squared to be equal to r squared, where h and k will represent some kind of a horizontal or a vertical shift. Okay, so let me just talk about this just a bit, because in geometry, sometimes you do transformations and sometimes you don't. It kind of depends on, where you're at and who wrote your curriculum or who wrote your scope and sequence for the school or the district that you're at. But in Algebra 1, and definitely in Algebra 2, or in pre-calculus or college algebra, transformations that we see for a function are pretty standard to use the letters H and K. So for instance, as an Algebra 1 or an Algebra 2 student, you have probably seen a quadratic function written in vertex form, where maybe we have a number in front of the parentheses, maybe we don't, it just kind of depends, but we might say x minus h quantity squared plus k. The h value is always going to represent a horizontal translation of some kind, where that k value is going to represent a vertical translation of some kind. And that's exactly what they're doing here. And a lot of times what we say is here, anything that's inside of the parentheses or radical symbol or absolute value symbol or whatever the case is, anything that's added or subtracted to the x value itself, a lot of times what we say is insiders lie, insiders lie. So for instance, if we had something that says h of x is equal to, in parentheses, x minus 5 quantity squared plus 2, a lot of us are going to look at that minus sign on the 5 and think that it's going to go to the left, but instead the insiders lie. So here, this would show that we would go right 5 spaces. If we had something that said, in parentheses, x plus 2 quantity squared minus 8, that right there, a lot of us are going to look at and say, well, because it says plus 2, it says go to the right, but insiders lie. So this means we would go left 2 spaces. And that's kind of why we're seeing the negative signs inside here. It just happens to be the way that the functions are created when we wind up putting equations together. So that's essentially what the standard form of the equation is for a circle. And down here, I've kind of given you a couple of examples that are not included in the notes, and you're welcome to include them if you want to, or just kind of study them and see what you have. And this is a pretty typical kind of example where we're centered at the origin. Those are going to probably be something that you may see in future math classes. For instance, when you're in, say, pre-calculus or trigonometry, you may wind up doing things that are called piecewise functions. Maybe in college algebra, you may do piecewise functions, and occasionally you'll be asked to graph a circle and maybe not the whole circle. Okay, so let's pick another color here, and let's take a look at this. What if I only wanted just this bit? What if I only wanted a semicircle? How would I do that? Well, I could take the function that was given to me, x squared plus y squared to be equal to 16, and we can put it in terms of y the way that we normally write things in terms of y for our functions. So I would move the x squared term over, and I would say y squared is equal to 16 minus x squared. And then we wind up taking the square root of both sides, and I would say 16 minus x squared like that. And if you happen to have a graphing calculator, go ahead and try graphing this thing here, and that would give you your semicircle centered at 0 with a radius of 4. But that may be something that you're expected to do in a future math class, is recognize the way that we write the formula or the equation of a semicircle. But the second example that we have here is telling us, based on what we see here inside of the parentheses, we're going to go right 2 spaces. This one says we're going to go down 5 spaces, because we basically do whatever is opposite of the sign inside of the parentheses, and that's how we wind up here at 2, -5 for the center of the circle. And this thing here, the 9, we just take the square root of the 9 to get r, and that's how we get a radius of 3. So that's how we can take the equation of a circle, whether it's centered at the origin or centered anywhere else, and identify what its radius is going to be, and do our best to just draw a circle. Maybe break out a compass if you need to, and draw a circle. Otherwise, do your best to freehand it. But that is essentially what we're going to be looking at for, the equation of a circle. And all of the things that we study in a circle's unit in geometry, the equation of a circle oftentimes is the thing that kind of gets cut out, because maybe for time purposes or whatever. Now, as you've been seeing in all of the videos that kind of led up to this one, that preceded this one, there's all kinds of properties with circles that, most students don't ever know anything about. You know certain things about circles as a, maybe an 8th grade math student, you know some terminology as far as diameter and radius and circumference and area and, things like that. But then we start getting into things like chords and secants, and how the, major arcs and minor arcs are named, and how we measure the minor and major arcs, and, the interior angles, the exterior angles, the angles on the circle or outside of the circle, or there's all kinds of relationships inside of circles that are limited just to geometry, and you're not going to see them anywhere else. But the one thing that you will see from a circles unit in another math class, maybe in an Algebra 2, a pre-calculus, college algebra, or calculus, you're probably going to see the equation of a circle again. So of all the things that you have for circles, obviously everything is important for the circles unit in your geometry class. However, if there's anything that you really truly take with you to a future math class, being able to write the equation of a circle or graph a circle based on the equation, that's really going to be useful. In Algebra 2, you'll study ellipses, and you'll need to be able to graph those in a similar fashion to what we do for circles. But anyway, let's get back to the task here and take a look at this example. Some of you may have figured this out while I was rambling, but it's asking us to write the equation of a circle from the graph that's been provided for us. Now, looking at the graph, we can see that it is centered at the origin. It has a radius of 2, and that is all the information that I really need in order to be able to write the equation of this particular line. So looking at it, the radius is 2 at the origin. So that means we don't have to add or subtract anything to the x values. You know, the normal standard form of the circle is x minus h squared plus y minus k squared equals r squared. Well, if h and k are 0, meaning because we're centered at the origin, then all we're left with is x squared plus y squared equals r squared. So whenever we're centered at the origin, it makes writing the equation just that much simpler. So in this case, we're going to plug in the 2 into the general form. So x squared plus y squared is r squared in this case, and substitute r for 2, and then square the 2, and our equation for this particular circle would be x squared plus y squared is equal to 4. And that's all there is to writing the equation of a circle. If you can see where it's centered, get its point that way, plug it into the general form of the equation, find the radius by just counting horizontally or vertically from the center to the edge of the circle, you get the radius, and then substitute that. So I'm going to go ahead and challenge you to pause the video and see, can you write the equation of the circle shown here and see what you're able to come up with. And presuming that you've tried working out the equation here, let me go ahead and show you how I have the solution written up. So again, I'm going to just start with the general solution or the general equation of a circle. I am a big believer that anytime you use a formula, you write it down so that way you remember it when you need to. A lot of tests that you have to take in academics don't allow you a formula chart, so have that equation memorized. And in this case, it's centered at the origin, so I'm substituting 0 for h and k again, which will result in just x squared and y squared. Now, one thing that students do have a tendency to mess up on for graphs like this is they don't necessarily see the scale. If you made a mistake on this one, I would imagine it's probably the fact that you said the radius was 3 as opposed to 6, because you didn't see that the horizontal and vertical lines are counting by 2's instead of 1's. So the radius of this particular circle is 6, so when I square it, I wind up with 36. So the final equation, x squared plus y squared equals 36. So hopefully you did okay with that one. And here, for some reason, they're giving us the standard form of the equation again, just in case we needed it for some reason. And what we're being asked to do on this example is essentially, this is the first example that we're seeing where the center of the circle is not going to be at the origin. And it's giving us a radius that's not an integer value. It's not like a 2, a 4, a 3, something that we can square in our head really easily. So you may want to have a calculator for the radius, because if you notice in this case, the radius is giving us to be a 3.7, some decimal value. And I always like to have a calculator whenever I square stuff like that. So they're giving us the formula for the equation of a circle, and it's up to us to make sure that we substitute things correctly. Well, because we're centered at 0, 5, this is h for 0, and k is the negative 5. So those are going to be the values that I'll wind up substituting into the general equation of the circle. 0 for h, negative 5 for k. Now, if you notice here, and let me pick some color besides red, so that way they don't blend together. If you notice here, we have that double negative. So that double negative creates this positive that we're seeing here in the next step. So x minus 0 squared is just x squared, but y minus negative 5 is going to wind up with y plus 5. And the calculator, when I typed 3.7 squared on the calculator, gave me 13.69. And there is the happy little equation for this particular circle. Hopefully you're not finding that too difficult. They're going to try and make things a little awkward at times to make sure are you paying attention to what was given to you and how you actually write the equation of a circle. Do you remember what the equation is? But Here, in this example, write the standard equation of a circle, and again, they're giving it to us in the form of a graph as opposed to just telling us where the center is. Now, in this particular example, they're going to make us, they're going to challenge us a little bit, okay? If you notice, the radius of the graph that was given to us, you know, here's the radius. It's about 1, 2, it's not quite 3. You know, it's greater than 2.5 and less than 3, but I don't want to guess at what that value is. So I want to know what is the actual radius, okay? And if you notice, they're giving us this point here to that point there. And we can use the distance formula, which is how the example, the way it was written for us, is giving it to us. Or we can recognize that we do have a right isosceles triangle, meaning that this is going to be a 45, 45, 90 triangle. So this is 2, this is 2. According to 45, 45, 90 triangle rules, the hypotenuse needs to be 2 radical 2. And if you type that onto your calculator, you're going to get something that's not quite all the way to 3, but it's going to be close to it. Now, we don't want to know what the actual decimal value is because in a math classroom, we want to keep things as the exact values. So anyway, let's get into how they're looking at it. So if you didn't form it as a right isosceles triangle, then you would need to make sure that you remember the distance formula. Okay, in this case, the center of the circle was given to you to be -1 and +2. And a point on the circumference of the circle, -3 and 4, between those points, we can write the distance formula to get the radius. So if you notice the difference of the x values is going to give me a -2, and the difference of the y values is going to give me a +2. But it doesn't make a difference, the fact that the difference of the x's gave me a -2, because I'm squaring it, I'm still going to get a +4. Now I'm going to go ahead and kind of expand this here just in case anybody needs to see it, because they're just going straight to the answer of 2 radical 2 here. But if you need to see it, the -2 squared is going to give me a +4. The +2 squared is going to give me a +4, which works out to be the square root of 8. Okay? Or the square root of 8, if you don't remember how you simplify it, is the same thing as the square root of 4 times the square root of 2. And of course, the square root of 4 is 2. The square root of 2 doesn't simplify, so that's why we leave it as 2 radical 2. Now, either way, whether we use the special right triangle rules or we use the distance formula, we get the radius of the circle to be 2 square root of 2 units long. And now what we need to do is we need to substitute the values for h and k along with the value that we have for our radius into the standard form for the equation of a circle. So I'm going to take the -1, substitute it for h, and the +2 and substitute it for k. And of course the 2 radical 2, we're going to substitute that into the equation for r. Now pay attention, because calculator-wise, this is where some students are going to make a calculator-wise, this is where some students are probably going to make a mistake. If you notice, they're putting the whole thing in parentheses. Okay, so if you're not sure how to mentally square the radical, put it in parentheses. Parentheses, 2 square roots of 2. Make sure you arrow to the right, so that way you actually close the parentheses outside of the square root symbol. And then you can hit enter. And when you do, you're going to wind up with that, whoops. When you do, you're going to wind up with that 8 that we had earlier, if we actually worked the distance formula all the way through. But the minus -1 becomes a +1. The y minus 2 just stays 2. And make sure that you can get 8 when you square 2 radical 2 on your calculator. So the final answer that we have is really just the x plus 1 squared plus y minus 2 squared equals 8. And that's how we are going to have the equation of this particular circle. They're trying to make it a little bit more difficult by saying that we're not giving you the radius by looking at it on the graph. You actually have to figure out what the radius is going to be by some other method, and then go and do your substitution into your equations of the circle formula. So here's the last one that I think that we have, if I remember correctly, that I'm going to do before you guys have some to try on your own. Now, instead of giving you the graph of a circle and ask you to create the equation of the circle, it's asking you to go the other way around. Can you determine what the graph of the circle will be based on the equation? Now, I kind of talked about what the parentheses did earlier in the lesson, meaning that essentially whatever we have here inside of the parentheses, we kind of do the opposite of whatever it says. So here, this says the x stuff is horizontal. So this, because it says -2, that really says we're going to go right 2 spaces. The y values, those are your vertical values. And here we kind of do, again, the opposite. That +3 inside of the parentheses really tells me I'm going to go down 3 spaces. Now, mathematically, we can look at it a little bit more, technical, in a more math-appropriate way, I guess you can think of it, is, anything that's going to give me a positive inside, because we have to subtract, according to the general form of the equation, we have to subtract whatever the number is. And the only way I can subtract and get a positive number is if the number that I'm subtracting itself is negative. So y plus 3 squared, the way that it would have looked on the last example, was we said y minus -3. And then we would simplify the double negative to be positive. And the 16, it's not really outright telling you, but remember, this is r squared. So if I want to know what r squared is, I'm going to take the square root of the 16, and that's where I'm getting the 4 squared from, because 4 squared and 16 are equivalent to each other. So the center of this particular circle is going to be at +2 and -3, and the radius, in this case, is just going to be a 4. Okay? So where did we graph it? Well, let's go to the center of the circle at +2 and -3. So +2 and -3 is going to put me about there. The radius in this case is 4, so I'm just kind of, trying to get my straight edge going either horizontally or vertically 4 spaces. Again, pay attention to how the graph is scaled. We're still counting by 2's on this one. That's why the center of the circle isn't, at an intersection of a horizontal and vertical line. But there would be so really what I would do, I mean on the computer here, I just kind of did the circle. I went to one of these things and I said, okay, look, here's a circle, and I just kind of put it on there and I did that. Okay, on my graph, what I would do is I would come here and I would make a mark, and then I would come this way, 4 spaces, this way 4 spaces, this way 4 spaces, and this way 4 spaces, and then I would do my best to actually make a circle going around. Okay, and here we go. We got 3 examples for you to try to work out on your own based on the last few examples that I worked out for you. So go ahead and pause the video, work out these 3, and then when you're ready, hit play so you can check work with mine. But presuming that you have done all of the work on your own and it's time to check your answers, let's see what we have here. Write the standard equation of a circle with a center -3, -5, and a radius of 6.1. So here, standard equation of a circle. Again, I'm a big stickler. If you use a formula, write it down. So substitute the -5 and the or the -3 and the -5 for the h and k respectively, and so we get those double negatives. Now, if you don't need to write them as a double negative, if you know they're going to become positive, you can go ahead and just write them as +3 and +5. But The double negatives inside of the parentheses will become x plus 3 squared and y plus 5 squared. And of course, 6 plus 1 squared I'm going to use a calculator for, and that gives me 37.21. So that is my final equation of this particular circle. Now, example number 3 here, or at least checkpoint question number 3, this is the one where you had to, going back to, where you needed to be able to figure out what the radius was because they didn't give you the radius. So I'm going to use the distance formula again to find the radius based on the information that they gave me. So they're telling me that the point -1 and 2 is on a circle with a center 3, -3. Now, I don't have a graph, and I didn't feel like graphing this one, so I'm just using the distance formula. I'm not going to try and do special right triangles like I had the opportunity to do on the last one. I'm going to just use the distance formula. In this case, I wound up with the radius of the square root of 41, which definitely isn't a very nice number, so I'm going to leave it as a radical. Okay, it doesn't simplify as a simpler radical. Square root of 41 is all it is. So now that I have the value of the radius, we can go to the general form of a circle and get the equation in this case. So again, substitute the -1 for h and the 2 for k, and for the x parenthesis, we wind up with the double negative, giving me x plus 1 quantity squared. The y parenthesis is just going to be y minus 2 quantity squared, and the square root of 41 squared is just 41. And so there is the equation of that particular circle. And then the last one here is asking you to graph the circle based off the information that was given to you. So again, I'm going to look at the stuff in the parentheses, and remember, the only way that I can get that positive 2 inside of the x parentheses is if the 2 is actually negative, because we have to say minus a negative to get that positive. So the x coordinate, or the h coordinate, I should say, of where the 2 is for the horizontal point of the center is going to be a -2. And the y coordinate of the center is going to be a positive 1. Okay. The radius, I just take the square root of the 9, and that's how I get a radius of 3. And then we graph it. And did I? It doesn't look, I don't know. There it is. I knew I had it on there somewhere. There's the graph of the circle. Now again, I used, on the computer here, I just said, okay, computer, give me a circle, and I just went to the center of the circle, and I just kind of played around with it until it got to where I wanted it to be. In reality, I would go to the center of the circle, and then I would go radius, 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 and then do my best to kind of freehand a circle. All right. Now this is, I think, the last example that I'm going to go over, and then there's one more checkpoint question for you to take a look at for equations of circles. Now here they're kind of giving you an application for how they're doing it, and it's almost like a treasure hunt what they're doing. Time capsule. You bury a time capsule and use a grid to write directions for finding it. So 50 years from now, when people are trying to dig this up, the information that they're giving is that the capsule is about 11 feet from the oak tree at the origin. Okay, so that gives me a circle like, oops, I didn't mean to do all 3 of them at once, but okay, we got all 3 of them here. So that's the red circle. So essentially I'm going to go from the origin, and I'm going to approximate about where 11 feet is, and I'm going to draw a circle. Now in this case, the scale is counting by 4s, so 11 feet is a little bit less than 3 squares horizontally or vertically from the center of the graph, but capsule B is 8 feet from the flagpole at 0.8. So 0.8 is going to put the center of the circle 8 spaces vertically from the vertex, or from the center of the from the origin. There you go. I knew I'd get to it eventually. And the capsule is also 4 feet from a mailbox located at -12 and 8. So we go to the left 3 spaces to equate 12 feet, and then up 2 spaces to equate 8 feet. And that's the little green one. So what we're looking at is essentially a system of equations with three circles. And just like what you saw in algebra, wherever the equation, wherever the graphs touch each other, that was the solution. And that's kind of what we're looking at here. The solution where all three of these things intersect. Whoops, didn't mean to do that. Right here, there we go. That should be where the time capsule is going to be located to here. So what do we know about it? Okay, A, it was at the origin. It had a radius of 11. B was at 0 and 8. It has a radius of 8. C was at negative 12 and 8. Has a radius of 4. And so when we graph all of those things, what we're looking for is where do they all kind of intersect? And that is where we're going to be able to find the coordinates for where the time capsule is buried. So in this case, we're going to approximate about negative 8 and positive 8 for the solution here. And here we go. This is the last example that you are expected to try and work out on your own based on what we have done on a previous example. In example 4, so the one that we just finished looking at with the time capsule, suppose the mailbox is at positive 12 and 8 instead of negative 12 and 8, and the time capsule is 4 feet away. Find the burial location of the time capsule. So go ahead and try working that one out. Go back to the graph and play around with it. See where you're going to end up at. And presuming that you've done that now, this is what I have. I just kind of took a screenshot of the graph that I had done before. So now it looks like almost like a face with ears, I guess. But I added the new one here. I added this circle here based on the fact that they're telling me that, let's say that that was the center. So I'm approximating the solution now is still where they're intersecting, all three circles intersecting, and in this case it was about positive 8 and positive 8 as opposed to negative 8 and positive 8. And that, my intrepid geometry student, is going to kind of wrap up the examples and material that I have for you for working with or writing equations of circles. Again, out of all the things that we have in geometry for circles, there's a lot of stuff special just to circles. And most of it stays in geometry itself. Some of the vocabulary that you're going to have with circles goes to other classes. Things like tangents and secants and chords and, I mean, obviously diameter and radius, but those are all going to be things. Vocabulary is going to be key. Vocabulary is always the key to being successful in math. Okay? The next thing that you need to make sure you remember is what the formula for the circle is. Okay? Because that is going to be something that will come up again in future math classes. It won't be a ton, but I guarantee you, you will see equations of circles again, or something that looks like it with an ellipse. And whether it's given to you in a graph to create the equation of the circle, or you're given the circle and asked to graph it, you need to be able to remember that the insiders lie. So whatever the sign says, if it's on the X, you go side to side. So if it says plus something, you go to the left. If it says minus something, you go to the right. For the Y's, that affects your vertical numbers. So if it says plus something, you go down. If it says minus something, you go up. Okay, and whatever the radius is, we have to take the square root of it to actually find out what the radius of the circle is. Say if it was given to as a number, like 9, radius 3. And that is all I really have for equations of circles. Anyway, thanks for watching. I hope you found this information helpful. And until next time, guys, thanks for watching. Take care and be good.